So this is a review of the multiple choice questions for the upcoming exam. Question 1. A hypothetical planet has the mass of 1/2 that of Earth and a radius of twice that of Earth. What is the acceleration due to gravity on the planet in terms of g, the acceleration due to gravity at the surface of Earth? The acceleration due to gravity at the surface of Earth is given by the equation small g equals big G over the mass of Earth divided by the radius of Earth squared. We are told on this fictitious planet the mass is going to be 1/2 and that the radius is going to be squared. What happens when you divide the mass by 1/2? So since the mass is in the numerator, it is directly proportional to gravity. So dividing the mass by half is going to cause gravity to be divided by half. So we know that already whatever gravity on Earth is, we're going to have to divide it by 2. We are then told that the radius is squared. When the radius is doubled, so since the radius in our equation is squared, when you double the radius, what is going to happen is that the denominator is going to end up being multiplied by 4. When you multiply the denominator by 4, the overall equation is divided by 4 because the radius and the acceleration due to gravity are inversely related. So that means in addition to dividing our gravity by 2, we are also going to have to divide it by 4. When you first divide some quantity by 2 and then subsequently divide it by 4, the net result is that that quantity is divided by 8, meaning that our correct answer is the gravity on Earth divided by 8. What is the total distance traveled by an object moving back and forth in simple harmonic motion in the time interval equal to its period when its amplitude is 2 centimeters? So for simple harmonic motion, it is following a sine or cosine function. Doesn't really matter how you draw it. You can either draw it like a cosine function like this or a sine function like this. No matter what, this is still a complete cycle. And the amplitude is from the equilibrium point to the highest point, that is 2 centimeters. No matter how you draw your function, the amplitude is always going to be 1/4 of the total distance traveled in a time interval equal to its period. Because a period is a complete cycle. A complete cycle has 4 stages. In this particular iteration, where's my laser pointer? In this particular iteration, the 4 stages are from the amplitude to the equilibrium, from the equilibrium to the negative amplitude, from the negative amplitude to the equilibrium, from the equilibrium back to the amplitude. Each one of those is 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters. In this particular iteration, we have the same thing, 2 centimeters up, 2 centimeters down, 2 centimeters down, 2 centimeters up. No matter what, we're always going to have 4 stages of 2 centimeters each. And as a result, it is going to be amplitude times 4, so the answer is going to be 8. If sound seems to be getting louder, which is the following is probably increasing, that is going to be the intensity of the sound. Intensity is related to amplitude, for what it's worth, but the intensity of the sound refers to how loud that sound is. A leaky faucet drips 60 times in 30 seconds. What is the frequency of its dripping? Frequency is cycles per second. Total number of cycles is 60. The total number of seconds is 30. The number of cycles divided by the number of seconds is going to give us the cycles per second. The answer is going to be 2 cycles per second. That is going to be the answer. Figure below shows a sine wave at one point of a string as a function of time. Which of the graphs below shows the wave where the amplitude and the frequency are doubled? The amplitude is this quantity over here. For the amplitude to be doubled, we would need that quantity to be larger. That rules out this guy over here. Sort of leaves us with, and this one, the amplitude is the same. Sort of leaves us with B, D, and E as potential candidates. We are told that the frequency is doubled. What is the frequency in this particular case? Well, this graph, as you can see, has a t over here. All these graphs have t over here, which means that the x-axis is measuring time in seconds, which means that the distance from crest to crest is going to be the period, because it is the amount of time it takes for the function to get from its crest back to its original crest, which is going to be a complete cycle. So this guy over here is going to be the period. When the frequency doubles, the period is halved. So we are looking for a function where this distance, the period, is halved. If this is the initial period, you can see that this particular graph over here has a shorter period, is where the period is halved, and therefore the answer is going to be D. Again, over here in this particular graph, we have a similar situation. We have t as our x-axis, which means this quantity over here, this length over here, is measured in seconds. It is going to be the period. And we were asked what the frequency is. The frequency is always going to be 1 divided by the period. The period is from 4 to 8. That means the period is 4. So if the period is 4, that means the frequency is going to be 1 over 4, which is 0.25. The amplitude is the same for every graph. The amplitude is always going to be the distance from the equilibrium point to the top or the bottom of the graph. In this case, it is clearly 2 centimeters. And then finally, at t equals 3, the object is at, well, this is t equals 3. The object is clearly at its equilibrium point. You can see that on the graph. Not really sure what else to say about that. Moving on. Over here, we do not have a time graph. We do not have time as the x-axis. This is actually a picture of a wave, and we are told that it is a standing wave. We're not actually told that, but you can assume it's a standing wave. We are told that the string is 6 meters and that the wave speed is 80 meters per second. What is the distance between two consecutive antinodes of the standing wave shown in the figure? So in this particular thing, we have an antinode over here and we have an antinode over here. I mean, it's pretty clearly to see. It's pretty clearly easy to see that this distance is going to be 6. So this distance over here is going to be exactly 1/3 of the entire graph. So here you have 1/3, here you have 2/3, and there's a half on either side. So the distance is going to be 2. What is the frequency of the standing wave shown in the figure? So in order to calculate the frequency, we are going to need to use the equation for frequency, which is F equals NV over 2L. L is given to us, V is given to us, 2 is 2 times 6. Here, let me draw that better. So we have 2 times 6. The V is 80. All we need is N. N is going to tell us which harmonic this is. This is a fixed string. So the first harmonic is going to be just this guy. So this and this is going to be the second harmonic. This, and this is going to be the third harmonic, which means N is going to equal 3. So we have 3 times 80 divided by 2 times 6. 3 times 80 divided by 12 is 20. The answer is 20. 20 hertz is the frequency of the standing wave shown in that picture. Which of the following wavelengths could not be present on a standing wave in a 2 meter long organ pipe open at both ends? So since it is open at both ends, the wavelength equation is wavelength equals 2L over N. We are told that L is 2. So the wavelength equals 4 over N. So all of the possible wavelengths are limited by all of the possible values of N. Possible values of N, well, N is the harmonic number. The possible harmonics are the first harmonic, the second harmonic, the third harmonic, the fourth harmonic, ... So the possible wavelengths are going to be 4 divided by 1, divided by 2, divided by 3, divided by 4. So all we have to do is look at all of our options over here and see which one of these cannot be formed when you divide 4 by a whole number like 1, 2, 3, or 4. So this one is obviously just 4 divided by 1. This one's 4 divided by 2. This one's 4 divided by 4. And this guy over here is 4 divided by 8. The only one that cannot be formed is 0.89 because 4 divided by any whole number is never going to equal 0.89. So therefore, that is not a possible wavelength on this particular standing string. Similarly, we have the next question, which is asking us about the possible frequencies of a standing wave. This one is even more straightforward because we are told the fundamental frequency is 500 hertz. If the fundamental frequency is 500 hertz, then every subsequent frequency must be a multiple of 500. Only one of these numbers is a multiple of 500. Only 1500 is a multiple of 500. Therefore, the answer is 1500.